The other one would be one solution. So your quadratic equation and your line are going to intersect once. Again, I'm not showing you pictures, but this is what it might look like as you're solving. So again, say you're solving a quadratic equation and you think two things that multiply to be 9 and add to be 6, you've got the same answer here. You only have one solution. This is a hint that that's what it's going to look like. This is another hint that that's what it's going to look like. 3 plus 0 and 3 minus 0 will give you that one, just one solution. Okay, the most common one that you will see will be a parabola and a line that goes through it and intersects it in two different spots. So these are the ones, again, if I'm using the factoring, I would have 3 different values. If I'm using the quadratic equation, there would be a perfect square root here. 3 plus the square root of 16, right? So this is kind of what we're looking at. This is the most common when you get your practice problems. I don't think there's any one solution. This will happen a few times. So be on the lookout for things that aren't factorable or have a negative discriminant. Yes, this one would have 2 solutions. Oh, I didn't write it. Okay, so what we're going to do now is we're going to practice one problem with substitution. We'll practice one problem with elimination. And then I'm going to have you practice some problems on your own, because there's not enough new stuff. I don't think me being repetitive is going to be that helpful. I think you trying some on your own will be helpful. Okay, the first one we're going to do, that is not it. The first one we're going to do is by substitution, if I can find it. Oh yeah, there it is. I will be writing the steps down, because I think sometimes that helps if you feel like you're getting stuck. So we have 2 equations. Equation 1 is going to be a quadratic. X squared plus x minus 1. We have a second equation. This one will be linear. Hopefully you can see the difference. One of them has an x to the power of 2. One of them does not because it's linear.
Wouldn't the first one have to have an equal sign for it to be an equation?
Yeah, it's y equals. So I got these steps from the book. What? Did you see something? Okay, I got these steps from the book, and the first one seemed like we didn't ever need to do it, but maybe one will show up. So step number 1 that they said is to solve both equations for y. All the examples that I saw moving forward were already like that. But in case they aren't at some point, we'll write it down. So if you get to some and that this isn't true, solve for y. Get everything on one side. Because it's already isolated for y, step 2 is we're going to take this expression and substitute it in for y in equation 1. So take the negative 2x plus 3, which this is going to change depending on your problem, but we'll take that expression and we'll substitute it into equation 1. Which is the quadratic equation. So give it a shot. Rewrite these. So instead of y equals, you're going to have negative 2x plus 3 equals x squared plus x minus 1. So instead of this y, I will put negative 2x plus 3, and then I can put the rest of that quadratic equation. So before we can factor this and find these solutions, it's got to be back in a standard form. So we're going to move this over to the other side. So I'm going to add the 2x with its like term, and I'm gonna minus 3. And I like to line them up under their like terms. So you notice I'm not putting anything under the x squared because there's no terms that I could combine with it. If you read right in standard form that doesn't make any sense to you, maybe you can describe that step in your own words. Move everything to the right. Okay, so we are trying to find the values of x where it crosses this other equation. So there's a couple different options right now. If you remember that blue paper I gave you that had all the different ways that you can find the solutions, you can see if it's factorable with the x. You can sometimes solve using square roots. The quadratic equation is helpful. I would never use completing the square if I were you. There's so many steps on that one. And all of those other methods get you to the same result. Oh, shoot. So I like to try this one because if it's possible, this is the fastest way and the easiest way. Josh, can you think of things that multiply to be -4 and add to be 3? What multiplies to be 4? What is it?
4 and 1.
2 and 2 or 4 and 1. So which one's going to work? Yeah. Some people caught on to the shortcut from the x straight to the solutions, and other kids just did not, as I was correcting the test the other day. So what this means is if I factor this quadratic, this is what it's going to look like. And we use what's called the zero product property. So before I do it, I think a lot of you are remembering the shortcut. Yeah? Like you already know what the solutions are. If you don't skip this step because you get all your answers opposite. We don't want that. So if you use the zero product property, it means we are solving both equations equaling to 0. Do you see the similarities between what we've done the last couple of days with substituting with linear equations? Just we're going to have most of the time 2 solutions. So once we get the x's, how do we find the y's? So to find the y values, I would plug these in, so we're going to substitute again. I would put it into the linear equation. I will have to do it twice. We're going to have 2 ordered pairs. So to find your y values, substitute these x's back into that linear equation. From the very beginning, it was equation 2. All right, so let's go through that. The equation was y equals -2x plus 3. So y equals -2x plus 3. And we do it twice. Y equals -2x plus 3. This will give us our 2 ordered pairs. These are the main differences from linear equations and nonlinear equations. So go ahead and solve those 2, and you should write your answers as ordered pairs. So you can finish solving those on your own and write your answers as ordered pairs. All right, Mallory, what did you get on the left-hand one?
-4.
Mm-hmm. Bergen, what did you get for the second one? Yes. So whether you're solving with elimination or substitution, this is what they're going to look like at the end. Okay, let's try an elimination one. And I'm going to show you what it looks like when you have no real solutions. You're going to have those same two equations. So equation 1 will be your quadratic. Equation 2 will be your linear equation. Yeah. You probably could. I just think it's harder when you're squaring. I just thought that one would be harder to solve.
So you just do one.
Uh-huh. I'll have to try it out. If there are a system of equations, it shouldn't matter which equation you plug it into. You should get the same y value because it's where they're crossing. Good question. Okay, if you look at this textbook to find the steps, I'm not going to follow this first part because it just said to subtract the equations. That seems like such a bad idea. So instead of subtracting the equations, we're going to multiply the linear equation by -1 and distribute it through. This is the same idea as subtracting it, but most kids would forget that you're distributing the negative all the way through. So I thought that was confusing. So distribute a -1 to the second or to the linear equation. I don't know if they ever switch the order of them. Then let's add them together. By doing that, we don't have to subtract the equations. We can add, just like what we were doing with elimination the past couple of days. There's some similarities there. So in order for me to add them, I'm going to come over here. I've got a -y. I'm not going to put anything underneath the x squared because it does not have any like terms. Okay, now I kind of hate that the example has opposite x's. That is not needed. Your x's don't need to be opposite. They just happen to be in this one. Most of the time they will not. So notice we're not worried about the x's being opposite. When you add the equations, your y's should cancel out. Or they should be eliminated. That's why we did this. It wasn't for the x's, which is confusing with this particular example. It's for the y's. All right, add them up. See what you get. I noticed it's too late. The x's canceled out. Too late to find a better example. Add them up. See what happens. And once you add them up, see if you can continue to solve. Find your two x values. Haley, what did you get when you added them together?
0 equals x squared.
So there's two ways, well, there's three ways to solve all of them. You got to pick the one that would be the easiest or the best. Any thoughts? Devin, how would you solve from here?
I squared it.
Square it? Is that what you said? Yeah. When there's two terms like this, when it's missing the x, like getting the x by itself is the easiest way. Can you factor it? Yes. Can you use the quadratic equation? Yes. Those are all going to be just fine. The easiest way on this one, though, so if you're like, how does Mrs. Mitchell know? I'm not sure what to do. Pick whichever way you like. Is anyone seeing what's going to happen on this one? Yes. for this particular assignment, so this assignment was supposed to be in the middle of last unit, but it made more sense to put it after we reviewed substitution and elimination. So when we had this lesson, it was before we learned what to do with square roots of negatives anyhow. So if I continue to solve, we're not talking about imaginary solutions. That's not what we're doing today, so no solution. Okay. Our homework, yeah. Oh, I didn't give us any steps. Oh, if you got to this point, so this is what I'm thinking in my mind. If I got to this point and I had x squared equals 16, like something lovely, okay, and we continued on, we took the square root of both sides, so x equals positive or negative 4, you would do the exact same steps as substitution. You will take the positive 4 and plug it back into the linear equation. You would take the negative 4, plug it back in and get the y's. So you would have 4 something, negative 4 something. So again, it doesn't always do this. If you continue down and it works, you have to go back here and find your y's. Okay, the assignment is from the textbook, but I'm not passing them out. So I took a screenshot. It's on your Canvas page for today. So if you want to go grab computers, on the Canvas I've got a calendar. Just scroll down and click on today. My modules aren't organized very well. It's all from the calendar. And then you'll do your work on a separate sheet of paper.